Okay, this is section 9.7, data and statistics or statistics and data graphical. Please make sure you get out your book for this one because I don't want to write out everything here. But we're going to talk about making a stem and leaf plot. A stem and leaf plot is, I'm going to write out the data for this one. We're going to start with example 2. Example 1, you can look at in the book. But example 2 is out there. And this one, it's a little shorter. Making plots can be kind of take a while. I'm going to write out the data here to show you exactly how to do it. And then the others, you're going to have to look at the book to see what the data is. So a stem and leaf plot takes stems from the beginning and puts them at the end. Now, for this, our stems are going to be thousands, and our leaves are going to be hundreds. So I'm going to round this to 3,700. This is going to become 2,800. I am going to round things correctly, 2,700. So I'm going to actually round, not just, no, not 2,700, 2,300. Going to round them to 2 digits. This one's 2,000, 1,900. They are all in order. And we're going to use what we call a split stem and leaf plot. So a split stem and leaf plot is going to, instead of doing all the ones together, so this would be a regular stem and leaf plot. Stems are going to be this column. Leaves are going to be this column. Let's do a different one. So a regular stem and leaf plot would look like this. And you list them in order. Now they listed this in reverse order, which is kind of odd, but I'm gonna put the leaves. So I'm gonna start at the bottom. Both of those are 1,400. You don't put commas, you just leave a little space. 5, 7, 7, 8, 8, 8, 9. Oops, nope. I didn't do this correct. 5, 7. I'm thinking about the next one. 7. Nope. This one is an 8. It's 1,800. 8, 8, 8, 9, 9. Then I jump to the ones that start with 2, which are these 3. And I get 0, 3, 8. How I read this out of the table, because I know that the leaves are in hundreds, 2 0 hundreds would be 2,000. 2 300s would be 2,300. And again, that's the rounded off version. And then 3, 7. We're going to do this into what's called a split stem and leaf plot, where you can split it. You can split the stems, the thousands, in parts. Now you need to split them into equal parts because what we're looking for here is really the shape of the data. And this is high here and it goes lower. Split stems will, for this particular one, will give us a better look because we don't have very many stems. So that means 1,000 to 1,400 or 1,499 really would be how I do this. But we did round. So 1000 to really 1450. 1450 to 1950 would go here. So I'm splitting these equally in half. So 4, 4. Now 5 is going to go in the second step. You could do these and you can't do it in, you can't split them in threes because 3 doesn't divide evenly into 10. Neither does 4. You can do it in twos if you have that much data crammed in. Now we have data that looks kind of like this shape, which if you flip it and turn it sideways, looks like this. And we'll call that shape skewed left. That's coming later. Okay. Example 3, we're going to do what's called a back-to-back stem and leaf plot for home runs by Mark McGwire and Barry Bonds. This is from 1986 to 2001. So I'm not going to write out the data for you. The middle is this is going to be what we call a back-to-back stem and leaf plot. I put the stems in the middle. And these were two of the premier home run hitters in this era. So this is about baseball. And yes, both of them use steroids. For anybody that's interested, it's why they hit so many home runs. So first I'm going to do McGwire. We've got 3 followed by 49. So it's helpful to put these in order. 49 is going to go out at the end of the 9 column. The problem is I don't know how many 40s there are until I do the whole thing. So it's good to order the ones. There's 2 from the 40s. There's a 22 and a 29. No, that's a 22 and a 29. I need to put it by the twos them for 22 and 29. So I'm reading this 22, 29. Get rid of those underlines. He hit 32 twice, 33, and 39 twice. He hit 42 and 49. He hit 52 and 58. He hit 65 once, and he hit 70. Barry Bonds' smallest season was 16 and 19. He hit 24, 25, 25. Hit 33, 33, 34, 34, 37, 37. 40, 42, 46, 49, and 73. Now, if these home runs went a few more years, we'd have a few more really high ones for Barry Bonds. But we can compare these. We see McGwire in this term had a couple more really high seasons. Barry Bonds had a couple more really high seasons after 2001. You can look at Barry Bonds and you see that the 73 looks like it doesn't really fit the rest of them. Indication of potential steroid use. Something changed, yes. Mark McGwire's seems to fit more. This 0-3, I'm guessing he was a rookie and he didn't play very much. Because in 87, he hits 49. 86, he hits 3. 87, he hits 49. He's got 2 years with 9 back-to-back. I believe he was injured. But if you look at Barry Bonds and sequentially, which we'll talk about a time plot in a little bit, really goes up around the year 2000, and it stayed up for a bit. Okay. Now let's talk about making a histogram. So that's a stem and leaf plot. A histogram is like a bar chart, except the bars on the x-axis are what we call bins, or they make they're numeric, and we group things numerically. So if we look at Mark McGwire's yearly home run totals, actually we'll go back to this one. We can read it right off the stem and leaf plot. 0 to 9, he's got 3. 10 to 19 is 0. 20 to 29 is 2. 30 to 39 is 5. 40 to 49 is 2. 50 to 59 is 2. 60 to 69 is 1. And this nice one, the going 70 to 79 category is also 1. He falls in there just barely. I'm going to fix a couple of these zeros and make them a little nicer. So a histogram is going to look like this. We've got ten, 20, 30, 40, 50, 60, 70, 80. And we're going to make the bar for 0 to 9 from 0 to 10. And that was 3. So it's going to look like that. And then a blank, 2. 30 is going to get up here to 5, which I made it just a hair low. 2, 2, 1, 1. So we can make a histogram on our calculator. So let's look at how to do that. So here, I got to get the calculator app open. And we're going to look at example 4, and we're going to use Hank Aaron, another big home run hitter's data. And it gives me the year. I don't actually care about the year for what I'm about to do, so I'm just going to enter the home run column. So this is 760, page 765, example 4. And I'm just going to go to stat. Oh, I don't know what I'm doing. I'm going to go to stat edit and enter data like I do in any list. Stat edit. I'm going to clear all of these. I really only want data in L1 for this. So I look at his first year, 1954. I don't care about the year. I just want the home run total for what I'm doing. So 54 is 13, 27, 26, 44, 30, 39, 40, 34, 45, 44, 24, 32, 44, 39, 29, 44, 38, 47, 34, 40, 20, 12, 10. There are 24 pieces of data here. Oh, no, 23 pieces of data. 24 is a blank line. So I've got all my data entered. I think I got everything correct. So what we're gonna do is we're gonna go to stat plot. So that's second y equals. We'll go to plot one. I'm gonna turn it on. And then we're gonna go down here to this thing that looks like a histogram. We can make several different types of plots here on the TI-84. We have the histogram. This is a modified box plot. This is a box and whisker plot. Modified just puts outliers as points. This is a line plot. We've used the scatter plot a bunch already. I'm not sure what the last one is, but we're going to use the histogram now. And instead of I don't know how I entered one, but I want L1. And I just hit delete there. Get rid of the one. There's only one thing here. And then we're going to go to zoom stat, and it will find our histogram. So I'm not exactly sure how this mapped my window. I might want to adjust it. Nope, I don't want the table. I want the window. My X min, let's set my max to be 50 to be an even number. My scale to be 10. That would make a little more sense. My Y min, let's make this 6. Make it an even number. -2, how about? I don't need to worry about that any of the others. So the scale tells me how much each one is going to go by. And it's not big enough. Let's make this 10. We'll go by 2s on the axis. And Hank Aaron never had more than that. Okay, so it looks like the book did it going by 5s on the x-axis. That might be a little better. Yeah, this shows a little bit more even distribution. So started at 10 because he didn't have any seasons less than 10. If you look in the book, they made the frequency table 10 to 14. So we had that. He had none. So 3 here because the y-axis is going by 2. So the marker here is 2, then that's 3. All of these are going to be whole numbers. Okay. So that is a histogram. We can look at it. We look at our histograms to get the general shape. So it's a kind of a general shape. Some are going to go under. That's maybe not the best drawing of my shape. Some are going to go under. Some will go over. And it's going to kind of fall off here like this. Maybe be just a hair lower. Again, you're not following this specifically, but it's kind of showing roughly the shape. Now if we had hundreds of pieces of data, this would be a little more even, but we've got 23. Okay. No histogram is going to follow a perfect shape. We're going to talk about shapes in 9.8 more. Okay. Overlaying a time plot or drawing a time plot. A time plot is a two-dimensional plot known as a line graph. Okay. A line graph, and on a time plot, the x-axis is time, so it's years, and you plot data points like this, and then you connect them. Some people want to do this when they have scatter plots. You don't do it for a scatter plot, you do it for a time plot. And you can see, so in example 5, they give a table in millions of units of CDs shipped to retailers each year, 91 to 2003. And it actually spikes around the year 2000 and starts going back down around 2001. I believe that's because of downloading music started around 2000. Downloading sites became available. And so what you can see in the time plot that they show is it going up. I can show something that's a little closer to the one that they gave. It's a generally upward trend. Looks like this. This little dip says it's going down for a year. And then this is about the year 2000. It starts going down again. There's a little dip between 96 and 97. Not a big dip, but just a little one. For whatever reason, less were sold. Maybe there weren't as many good hits that year. I don't know. You can overlay two time plots, which they do the CDs one, versus cassettes sold. Not sure if you guys know what a cassette is, but it's an old type of way of listening to music. They don't sound as good as CDs, but it's kind of a thing from the 80s. And, throughout the 90s, it was decreasing. And I know we didn't have a CD player when my family did not have a CD player in 1991. We got one in like 93 or 94. We had cassette players, and then we still had our cassette tape deck because cars had cassettes and a lot of other things had cassettes. So as CD sales increased, cassettes went up. You could probably overlay this if we did this further into the 2000s. You could overlay downloaded music versus, which might be a little harder to track, but downloaded music versus CD sales. And you might have to divide downloaded music by, 10 or something. That's a whole CD worth. And you would see CD sales going down, downloaded music going up. The thing that would be interesting to track here would be legal versus illegally downloaded music, where legal being where the consumer of the downloaded music pays for it, illegal being where they don't. Okay, that's the end of section 9.7.